Today, I'd like to implement Dead by Daylight inspired vaulting for first person. A lot of tutorials are already out there using fancy techniques like motion matching, etc. to get the result. And since in a first person game you won't really have an animation, we are going to have a much easier time working with it. Let's get started. First off, we are going to replace our jump. Jumping will no longer be allowed for our character, but this is mostly just because it's easier to use this input, and in horror games jumping often isn't allowed. So when it's triggered, we're going to make some space. What we are going to do is we're going to actually shoot out a ray. So what we're going to do is we're going to box trace by channel. And this one has a lot of very hard components to it. But what we really want is a half size of 32. I found works well. And then for the start, for the end, we're going to create a new macro, which we are going to call calculate trace location. So this will actually trace, and it's going to have two outputs, namely the beginning and the end, and two inputs, one which will be called trace and the other should be called range. And the range can be a float, the trace can still be a boolean. I'm actually going to set the default to true, and the beginning and end should both be vectors, so we can plug it into our box trace here. So what we're going to do is we're just going to grab it, set the range of the initial one to 150. The values can be played around with quite a bit, and this is our first trace. Well, from that we're going to call out a branch, and this means, hey, there's something in front of us. So we also want another parameter. I am going to move it above trace. Let's call it offset, which will also be a float. So what we're going to do now is we're going to get the actor location of ourself, break this vector. Then on our Z, we're going to add two floats together. That will be the offset. And then we're going to make vector with our Z, our Y, and our X, which will go into the beginning, but they will only go into the beginning if trace is true. So we're going to put a select vector here and place that into the beginning. So we're going to, if trace is on, which by default it will be, this will be our beginning. So for our end, what we want is get the forward vector. Get actor forward vector. And then simply multiply this by a float, which will be our range, and then simply add this together with our beginning. And that will be our end location, which means that if our trace is off, we'll just have a static location, which will be the end. Alright, that's all looking good. If we go back to our event graph and set our offset to 50 by default and 150 for the range, let's head to our viewport. I like to get the camera to 0 to make it centered. It feels much better that way. And it will also help us later, but we can keep it at 60 for our Z value. And I always like making it a little bit smaller. but we will need these values. So I often just go for 42. If I enable draw debug type and put it on for duration, what is going to happen is it's going to send out a beam from my screen and check if there's nothing in the way of my face. So this will basically be the max height I will be allowed to vault. Alright, so now that we've made sure our view is free, what we can do is do another box trace. When we've not hit something, that's important. So what I'm gonna do is quickly make something that's vaultable. So I'm going to copy these by holding Alt, rotate them around, maybe add them together, and hold Alt to copy them again. These will be our test platforms. And I think physics is on them. So we'll just disable simulate physics on these, but this is just for testing because they are the correct height. All right, what we're going to do is copy the calculate trace location because we're going to use the same ID again. The only difference is that our offset will be -20. So this will shoot a ray out from our feet to check, okay, something is both beneath us and there's nothing on eyesight. So in the middle somewhere, there's the border, so we can vault through it basically. So only if this is true will we continue. We can print a string and say vaultable. So if we run this, now it will shoot 2 rays, basically perpendicular. And here we can see the bottom hit something, the top didn't, so this is vaultable. But it will also say it if it exceeds our range, right? So if there's something behind it, it still says we can vault. And that's something we are going to fix right now. So if this is true, we're going to do a capsule trace by channel. We're going to copy our calculate trace location again. And this time we're going to disable trace. So our range will be about 300 and our offset will be 26. I found works well. And then our radius and half height will actually be the same radius and half height as our capsule component. This will be 42 and 96. And we're also going to draw this for duration. Now, well, I've accidentally used a multi-capsule trace by channel. Make sure you don't use any multi. We're not interested in any other components. We just want to know if we hit something. It doesn't really matter what we hit. So our radius will be again 42 and our height will be 96, or half height at least. And we're going to make a branch, and only if this is false as well, what we're going to do is print a string and say this is vaultable, because I didn't enable draw debug for this one. That's my bad. And there we go. This will be our end location when we vault. We can also maybe lower this. I think in my production environment I have this on 200, which we can also easily do. Maybe even lower this range a little bit. But these are all settings you can play with to really give the right feel to your application. So what we're going to do here is we're going to need this end later. So make sure you have this somewhere, because this will be our vaulting location. We run it once more just to test. Yeah, we should be able to vault this. This looks perfect to vault. So let's do the actual vaulting. So first thing that we want to do is create a new variable and call this previous vault location. And this will be a vector. And very simply, we're just going to set this to get actor location. Remember how I told you we need this end? Well, we're going to set our actor location to our end. So if we just drag it over here, it's going through all our stuff, which isn't nice. So double click on the line to add reroute nodes so you can neatly organize it. And there we go. Set our actor location the moment we are able to vault. So as you can see, it is a vault, but it isn't very nice yet. There's no animation. You're just instantly on the other side. How I resolved this issue was by getting the player controller and disabling the input, which might sound weird. Disable input and not our target. Let's go into the player controller. If you're wondering how I quickly disconnected the line, just hold Alt and press on it, and that will disconnect the line. So we're going to disable our input and add a timeline. Vaulting timeline. And every time we play this, we're going to want to play from start. And it's very simple. How long do you want your vaulting to last? Well, I just want 0.5 seconds. Want it to be quick. You can make it even quicker, like 0.25. But let's keep it at 0.5. Very quick vault. And let's call this the alpha. So really what we want to do this smoothly is go from 0 to a alpha of 1. So value 1 and the time actually 0.5. You have these two handy buttons which zooms in to do it properly. Well, on our update, first off, we really want to enable our input again. Not having input isn't very nice, so enable input when it's finished. But on our update, what we are actually going to do is get our first-person camera and set the world location to something maybe a bit hard, but our previous vault location will be used, and our get actor location will be used, because our actor location, if you remember correctly, we've updated, but before we've updated it, we've set it. So this is our previous location, this is our current location. So we want to lerp between these. And what lerp does, it basically interpolates between two values. It's a linear interpolation. So if it's at 0, it's just going to be value A. But in the end, we want it to be value B. So the alpha, if I set this to 0.5, it's the exact middle point between my previous location and my current location. If I set this to 1, it's just going to be my current location. In our timeline, we've established that our alpha in the span of 0.5 seconds will go from 0 to 1. So we're going to plug this into the alpha and then plug this into the new location. Every time we update, we're going to update the world location. So when we do this now, As you can see, it works, but not quite. What we can do is go to our first person character, and when the camera is ready, we'll just set relative location back to 0 and then 60 on the z-axis, because remember, our camera location relative is 0, 0, 60. So when we plug this in, at least it will set us back correctly. But you may have noticed something a little strange. We're going through the thing. So what we are going to do is a relatively simple, but in my opinion, elegant solution. We're just going to drag this down, drag this right here in front. And since our X and Y are exactly how we want them now, if we split this truck pin, we split this truck pin, we can just plug in our X and plug in our Y. Now let's see if we can clean it up a little bit, because this really doesn't look very good. Let's put our camera here, maybe take this, maybe make the lines a bit shorter. There we go. To make the animation and actually get our head at the correct level, we're going to create a new macro. Let's call this calculate head height. We're going to need an input and an output. Our output will be the height. That will be our actual z value. And this will be our animation. So that animation, going back to our event graph, will be specifically for adding offset to our z. And we can do this quite easily actually by going into our timeline, adding a new track. Let's call it a flow track. Let's say animation. Well, in the beginning I want it to be 0 because we don't want any snapping. And in the end I also want it to be 0, but at 0.5. And then in the middle, maybe we can at 0.1 make it minus 10. And then add another key at 0.25. Maybe I want to make this 50. So there we go. We are going to add this offset to our head position. So get actor location, split the struct pin. We're not going to do anything with the X or Y. And our previous fault location, we're also going to split, and we're also not going to do anything with the X or Y. And we're going to add 60 to our Z value. And why 60? Well, that's the value our first person camera has. So the offset of our actor location is 0, 0, 60. So on our z-axis, we're going to add 60 to keep it consistent. And then what we're going to do is lerp between two values, these two, based on our alpha, which we haven't actually added yet to our calculate head height. So add another input, call it alpha. And the alpha and the animation, let's maybe reorder them. Yeah, that's way slicker. So here our alpha will go into there. What we're going to do is we're going to add our animation to this lerp. And what this is going to do is this is going to act like an offset. So it's going to add 0 in the beginning. So that's our actual height. Then at 0.1, it's going to add minus 10. So it's going to go to minus 10. And then at 0.25, it's going to add 50 to our current location. So that will give the animation ID. So when I now do it, as you can see, we have an animated vault. It plays on us on the other side, and we have a nice little animation to get there. If you enjoyed this video, please follow for more, and I will see you in the next one. Bye bye.